Americans are pushing back on the massive buildings that make artificial intelligence possible, and the resistance is crossing every major political boundary. This chart tracks public opposition to new local data center construction. Over just a few months, resistance climbed to 61%, a sharp spike from a baseline of 49% earlier in the year. If you ask voters why they oppose these sites, they aren't worried about computers becoming self-aware. They are looking at the immense amounts of electricity and water these facilities require to operate. Here is what one of those footprints actually looks like: giant warehouse-scale modular units, drawing cooling water and power directly from the local grid. The tightest constraint on the AI boom is no longer the mathematics or the software. The hard limit is physical reality and exactly how much infrastructure a local community is willing to tolerate. Consider the scale of OpenAI's infrastructure roadmap. They are planning a $400 billion build-out across 5 new data center sites in the United States. The target for this project is to eventually draw roughly 7 gigawatts of computing power. Grids simply cannot absorb that kind of infinite expansion. Tech companies have realized that relying exclusively on scaling up massive physical warehouses is a dead end. To keep building useful tools, the focus of the global race has pivoted away from maximizing raw intelligence and toward maximizing extreme efficiency. OpenAI's attempt to cut their power budget starts with a custom-designed piece of internal hardware named Jalapeño. Instead of relying on general-purpose chips, this design targets the specific math needed to run AI. Early tests show it executing up to 1.9 times more work per watt of electricity compared to Nvidia's current leading processors. To achieve these gains, companies are manufacturing highly dense, bespoke silicon architectures packed onto wafers exactly like this one. This pivot to specialization applies to software too. When a financial technology company named Ramp needed a coding assistant, they bypassed the massive cloud providers entirely and built an internal tool named Inspect. Inspect operates inside a cloud sandbox wired directly into Ramp's specific databases. Because it understands the company's internal context, it completes tasks more accurately than a much larger, blind model guessing from the outside. As a result, this specialized in-house system now writes 75% of the code that gets merged into the company software. Whether it is a physical computer chip or a digital coding agent, hyper-specialized tools are proving that tight, targeted systems can beat massive generalist monopolies. The primary obstacle engineers face is that stripping away a model's parameters to make it smaller typically destroys its ability to reason, causing the neural network's logic to degrade as it compresses. A new technique called quantization-aware healing fixes this. Instead of creating a damaged copy of a large model, it trains the smaller, compressed model to actively imitate the high-quality outputs of the original. This diagram illustrates the memory footprint of that process. The data block shrinks to just 25% of its original size while preserving its structural integrity, meaning the model retains its reasoning skills while using a fraction of the space. Another approach filters out useless information before the model even turns on, a routing technique that trims the data an AI has to evaluate. A tool called Agent Weave narrows the list of options the AI is allowed to see, cutting the input text by 61%. With less data to process, the model responds faster and uses far less compute power per query. By hacking the software architecture to handle choice and memory more intelligently, engineers are making models lean enough to exist entirely outside the walls of a supercomputer. This efficiency push has sparked a movement called local-first AI, where highly capable models run entirely offline, keeping user data permanently secured on the device. The open-source CarWatch project pushes this localization to the extreme. It runs a 35 billion parameter AI model completely offline inside a vehicle, powered entirely by a Raspberry Pi resting in the palm of a hand. Major corporate players are adapting to this hardware reality. IBM recently released its Granite models in small, laptop-ready formats, totally free for commercial use. Squeezing massive computing tasks into tiny hardware environments democratizes the technology, shifting control away from centralized tech giants directly into the hands of independent users. The initial fears of a future dominated by a few power-hungry cloud monopolies are giving way to a computational reality that is highly fragmented and efficient. Shrinking the architecture from macro data centers down to micro devices reduces the immense strain on local grids and solves the privacy risks of sending personal data to the cloud simultaneously. The trajectory of computing isn't about scaling up to the size of a city, but scaling down to fit in your pocket. The arms race to build the biggest possible machine is dead, replaced by a quiet, local revolution where radical efficiency wins.